Tonight on the Astronomy Show, professional astronomer Dr. Jaymie Matthews gives us insight into comets. We hear from amateur astronomers and their first-hand view of the Shoemaker-Levy comet crash. And David Dodge tells us what to look for in the skies this next month. All this and more on the Astronomy Show.
Welcome to this month's edition of the Astronomy Show. Tonight we're doing a show on the crash of Comet Shoemaker-Levy into Jupiter in July 1994. This event is unique in the annals of astronomical history for several reasons. First of all, the human race had almost a year's warning that this was going to happen. Second of all, this was never seen by any human before, a crash of this magnitude. Third, the professional community was able to marshal its forces together to observe this event. And fourth, this event was so spectacular that any amateur astronomer using anything from the smallest possible telescope all the way up could see this all from his backyard. Probably this qualifies as the astronomical event of 1994, if not of the 90s. With us this evening, we're going to have several guests. We're going to have some local Vancouver amateur astronomers who took the time to actually see this, and they'll be giving us some of their thoughts, what they saw and what they felt watching this event. We also have with us this evening Dr. Jaymie Matthews of the UBC Astronomy Department, who will be giving us the professional viewpoint of the crash, what happened, why, a few thoughts as to what they saw, and hopefully maybe we'll have some of the early results. So welcome to the Astronomy Show, Jaymie.
Thank you very much, Barry.
Glad you could come. I suppose the thing to start off with is, why is this event so noteworthy? Like, comet crashes into planet, so what? Are my property values suddenly going to go down because of this?
Well, not if they crash into Jupiter. As you pointed out, I mean, this was an event which was unprecedented in human history. Nobody has ever seen a comet split apart by the tidal force of a planet, as Jupiter did to Shoemaker-Levy in mid-1992. Nobody has seen a comet of this size, or anything of this size, slam into a planet. The only people who have come close in recorded history are a handful of Tungus hunters on the Siberian steppes in 1908, who witnessed a mere fragment, probably a tenth of the size of the fragments of Shoemaker-Levy, more like a 10,000th of the mass, exploding above the ground there. That flattened trees for 20 or 30 kilometers in all directions. Comet is nothing more than a big dirty snowball, and at great expense, UBC, Rogers Cable, and various people have provided me with this wonderful demonstrator model of a comet. Let's start, well, forget the tail for the moment, because actually comets don't always have tails, and let's just consider, here is a model of what you might consider the nucleus, the core, the heart of a comet would be. Except you have to scale this up. One, it's not made of rubber like this ball, it's made up of ices, and not just frozen water, frozen methane, frozen ammonia, mixed in with lots of dirt and dust. Astronomers would use the word dust grains, but essentially it's dirt. It's not unlike going out in a snowstorm and making a snowball and mixing a little bit of gravel in it. Except you've got to scale this up to something, a snowball, that's about 10 kilometers across on average, and would have the mass of about Mount Baker on the other side of the border. So if you can think of those in those terms, that's a run-of-the-mill comet. Every once in a while, one plummets in, and as it approaches the sun, the ices are warmed by the sun's radiation, and it evaporates. It releases gas and dust into space, and all that gas and dust is pushed away from the sun into what we recognize as a nice long curving tail by the combination of something we call the solar wind, a stream of particles that's going outward from the sun in all directions, some of which hits the Earth and indirectly is responsible for the aurorae, the northern lights, and also the physical pressure of sunlight itself. It exerts a very weak force on the small particles of dust and forces them into tiny orbits. And so through all of these interactions, you end up getting this beautiful tail, which always points away from the sun. People kind of have a picture that it's a bit like a jet plane with a contrail going behind it, but when the comet's leaving the sun, in fact, the tail is in front. It's moving like that. So that's what we're seeing. Some comets are in periodic orbits. The most famous, the one with the best PR person anyway, is Halley's Comet, which comes back every 76 years in a very elongated orbit, but one that doesn't leave the solar system proper. Other comets come in, sweep past the sun, and go out into the depths of space again, never to be seen again in human history.
What exactly did you see?
Well, a big black mark on Jupiter. It reminded me pretty well like throwing a pebble into a mud pond or something like that, and stuff coming up from the bottom and spreading out over the water. I had that kind of impression, sort of intuitively, if you like.
Gary, you're known in the Royal Astronomical Society as the Jupiter junkie of the club. You certainly enjoy observing Jupiter. So I imagine you were waiting for this crash. When did you first see something?
Well, I guess shortly after the first impact, and I don't recall what the date was on that. But unlike most of my friends, I didn't have a television set going, so the first time I actually saw anything was through the telescope. And of course, I'd heard that there were impacts that were visible. And I was more than a little surprised that this detail, that this feature would become so obvious, because I think those of us in the astronomy community were preparing ourselves for something that would be subtle at best and impossible to see at worst. And to see something that was quite easily the most distinctive surface marking on Jupiter was quite a surprise.
Falls a little short of a solar eclipse, but it's the next best thing to it.
We're accustomed to seeing the shadows of Jupiter's moons moving across the planet, and those are very, very dark. And these were similar in darkness to that. They were very prominent features. And they were about as dark as shadow transits, with a larger area involved. In fact, the larger impact areas rivaled the Great Red Spot, that cyclonic storm that's been going on Jupiter for hundreds of years. In terms of size, they were about that big.
Good luck it's happening on Jupiter, not on Earth. I would imagine that if, judging by the size of that and, knowing something about astronomy, its appearance on Jupiter was much bigger than Earth would appear at that distance. And, we would have not had to worry about our next cup of tea, I would think.
Shoemaker-Levy was a comet which was unfortunate enough to be captured by Jupiter. It was orbiting the sun, but it came by accident so close to Jupiter that Jupiter trapped it into an orbit around itself, a very elongated orbit, which went around like this. And in fact, on a passage in July of 1992, it came so close to Jupiter that Jupiter's tides, the same effect that the moon exerts on the Earth to cause the oceans of the Earth to bulge out a little bit and create high and low tides, those tides exerted by Jupiter on something like Comet Shoemaker-Levy were strong enough to rip it apart into 20 or so odd fragments, which continued on in the same course, and then eventually the distortion of the orbit was such that the next passage near Jupiter wasn't just a near miss, it was a collision with the surface, or in the case of a gas giant like Jupiter, the cloud tops.
I believe this is the first time that not only has this been seen, but we had almost a year to prepare for this. Can you sort of give a brief overview what the professional community's preparations were to see this thing?
In fact, things like the Hubble Space Telescope were able to look towards Jupiter and take pictures just before the end, like this one, showing all of these fragments heading in towards the gas giant, like a freight train barreling in on the track. So it was unusual that we could predict to within a few hours when these events were going to occur. And that doesn't happen very often in astronomy. So most of the world's observatories, which were equipped to do any kind of studies of Jupiter or of comets, both taking pictures, both obtaining spectra of the planet and the comet, and space observatories, like even the Voyager probe, which was already in the outer solar system, was able to look back and make some measurements. The Galileo space probe en route to Jupiter actually had a better angle on the impacts than we had from the Earth, or the Hubble Space Telescope, which is in low Earth orbit, suffers the same problem. The impacts occurred just on the other side, tantalizingly close, but just around on the other edge of Jupiter. All of these things were able to be prepared to look at Jupiter over the week in which these things were happening. And astronomers were fairly conservative. In the past, we've been burned. We've had fairly high hopes for events which have turned out to be fizzled a little bit. And in this case, we were extremely conservative in our estimates of the energies and so on, and the consequences. We didn't want to build this up too much. Even with the very low-key approach that we had, people were still worried that impacts of our conservative estimate of 100 million megatons in space, even at the distance of Jupiter, 750 million kilometers away, was going to somehow affect the Earth. I mean, and that didn't happen. As Marvin the Martian might say, where's the earth-shattering kaboom? There really wasn't one. There wasn't even a Jupiter-shattering kaboom, because Jupiter's awfully big. But certainly on a human scale, there was a kaboom of massive proportions.
Night we were disappointed. We were ready for Fragment B. Fragment B's impact time came and went, and we observed the spot for about 2 hours afterward and saw nothing. Not a trace, no observable effect whatsoever.
So what was the first impact site you eventually did end up seeing, and when was that?
Well, it was the very next night, on the 17th. I had just finished building a 16-inch telescope, and I was out star testing the telescope. I wanted to check out the optics. So I had it pointed at a star, and then after I'd finished star testing the telescope, I thought, hey, I'll point it at Jupiter, see if anything has happened by now. And I pointed it at Jupiter, and I was stunned at what I saw.
And what was that you saw?
Well, I saw the impact sites of fragment A, C, and E, all stretched out in a line across Jupiter.
I remember there was a comet back in, I think it was 1979 or 1980, called Iris-Araki-Alcock. And this was a remarkable comet in as much as that through the telescope you could actually see it moving against the star background. And although we live in a very dynamic universe, we're accustomed to seeing it in static terms. We don't often see things actually happening. And that comet was something that was actually happening. And this impact on Jupiter was also something that was actually happening. It was real-time, live event happening in the universe, and this is something that's quite rare. So I would put it up on a par with a really good comet.
Yeah, I was interested in the megatonnage as well, and here's what I came up with. Okay, we know that there were the energy of 6 trillion tons of TNT were released. That's like 6 million 1 megaton nuclear bombs, or as you say, about 200 times the world's entire arsenal of nuclear weapons detonated in one spot.
Space Telescope image of some of the quote-unquote scars that were left behind. People were surprised, astronomers were surprised that there were these dark, persistent dark features. We didn't really expect that. It appears as though whatever it is material which is floating above the normally bright surface of Jupiter where the cloud tops are and obscuring our view of beneath. So it has to be something which isn't reflecting a lot of light and doesn't let much light through it. And the best idea is that these are probably compounds of methane. There's a lot of methane in comets, and there's a lot of methane in the cloud tops of Jupiter. And so at high temperatures and under these kinds of impact conditions that probably mix together in molecular compounds and maybe even stick together in fluffy grains of dust, the kinds of things that you find in the corner of your apartment or home when you haven't cleaned up for a few months. And these cosmic dust bunnies of methane compounds were floating above the cloud tops and basically obscuring our view behind. And that's why they were able to survive so long, because normally features in Jupiter's atmosphere are shredded by the fact that it's rotating so quickly. The planet goes around once every 10 hours or so. And so basically any feature on it gets spread out into a band. And yet these features persisted for a while because they were up above most of the atmosphere, up above most of these shears, like a jet stream in the Earth's atmosphere. So they were able to last for days and weeks, and they have been spread out, and there may be a permanent band feature left behind. That's the best idea now. People are still scrambling. It may have been months since the impact, but it's going to be probably realistically years before we have a very firm idea of everything that went on in the sequence of events in these collisions.
Is there any indication or any early scientific results from this crash? Have we learned anything new about either comets or Jupiter or both, or anything else that were previously unknown before this happened?
We learned that these fragments were probably denser than we expected. They probably didn't contain as much water and icy material as we thought. So perhaps they were less comets in the traditional sense, which was ice with a little bit of dirt mixed in, and perhaps more rocky bodies like asteroids with a little bit of ice mixed in. And that may have implications for the structural nature of comets. The way that Shoemaker-Levy was split apart by Jupiter's gravity, the way that fragments split apart as we watched, as Hubble took images, tells us something about their structural integrity. The fact that some fragments disappeared from view, and we've always wondered whether we've seen comets sort of break apart and disintegrate, and we've always wondered whether they sort of spread out into a swarm of tiny particles, or whether they're actually broken up into a bunch of loose, kind of gravelly conglomerations. And in the case of some of the Shoemaker-Levy fragments that disappeared, even though we couldn't see them right on schedule when they should have hit the surface of Jupiter, there was a spot that was left there. And so there was something there that left a mark on Jupiter, just too small for even the Hubble Space Telescope to resolve. So that kind of answers the question in one case, that yes, these things that when they disappeared, maybe they don't really disintegrate the way we thought. As far as Jupiter's atmosphere goes, I think we're going to learn a little bit more. The way the comet plowed into it and churned up gases and molecular compounds at different layers, like ammonia and acetone and so on, is going to tell us a little bit more about the segregation of how these compounds change as you go deeper into the planet. And we're still curious about whether the comet impacts actually cause the whole planet to vibrate and ring, like hitting a big bell with a gong. So I think it's still early to say, but it's clear that there were results which were unexpected. And whenever we see things we don't expect, that means we're going to learn something.
Welcome to Astro News, the part of the astronomy show where we get to talk about what's in the nighttime sky. Well, there's one particularly bright planet we can see in the evening sky, and that's that one that's just over my shoulders. That's the planet Saturn, the ringed planet, the most beautiful planet in our solar system. But if you want to see the planet's rings, you have to have a telescope giving you a magnification of 33 times or more. We'll talk more about Saturn in just a few minutes. There are some stars that we want to talk about right now. And directly overhead is the star Vega. Just to the east of Vega is the star Deneb. And down closer to the horizon, just above Saturn, is the star Altair. And over in the west, just after sunset, you'll see a bright reddish star. That's the star Arcturus. Besides Saturn, we have two more planets in our nighttime sky. Just after sunset over in the southwest is a really bright star. That's the planet Venus. And just above and to the left of Venus is Jupiter. Jupiter was very important this past summer, as we heard earlier. If you want to identify the planets, the best thing to do is follow the moon. The moon goes around the Earth. It takes about a month to do so. And as it does, it passes by all the planets. So let's identify the phases of the moon. They are new moon, first quarter, full moon, and last quarter. New moon was on the 4th of October. When the moon is new, it is between the Earth and the sun. It sometimes gets exactly between the Earth and the sun, and we call that a solar eclipse. The next new moon in November, November the 3rd, the moon will be exactly between the Earth and the sun. We'll have a solar eclipse as seen from Peru, Chile, Bolivia, and Argentina. On the 7th, the moon passes by both Jupiter and Venus. And on the 15th, passes by Saturn. So if you can't see Saturn now, wait till the 15th when it'll pass right by it. On the 19th, the full moon is called the Hunter's Moon. Now, Saturn is that planet just over our shoulder here. Saturn is the ring planet, the planet with the beautiful rings that you can only see if you have a telescope. If you don't have a telescope, why don't you come down to the Gordon Southam Observatory, right next door to the planetarium, because we'll be open every clear Friday, Saturday, and Sunday evening to look at the planet Saturn. Now, the rings of Saturn right now are not quite as open as they were last year, because we are passing through the planet's equator, and that'll happen next year. We have something special for you later this month. On the 22nd of October, the Earth travels through the tail of Comet Halley. Comets are aggregates of frozen gas and dust, and when they get close to the sun, the heat from the sun warms up the gases and releases the dust. And just like Hansel and Gretel, that dust is left behind, marking forever the path of the comet. On the 22nd of October, the Earth passes through Comet Halley. We call that the Orionid meteor shower. Just as we had a major meteor shower in August, the Perseids, we're having a minor meteor shower, the Orionids, this time caused by Comet Halley. Don't forget to turn your clocks back at 2 o'clock in the morning on October the 30th when we go back to Pacific Standard Time. If you want to learn more about the space sciences and astronomy, come down to the planetarium for the next Royal Astronomical Society of Canada Vancouver Centre's meeting. For more information about the next meeting, please phone 738-7827. For the Astronomy Show, I'm David Dodge.
I think David Levy put it perfectly when he said we should put a sign around the solar system that says solar system still under construction, watch out.
Yeah.
Well, I suppose being at the end of the interview now, do you have any final parting thoughts on this Jupiter shaking event?
Well, I think, again, it's a reminder to us that these things happen in the solar system, and we see evidence on the Earth of impacts in the past. Many scientists are firmly convinced that an impact of a comet led to the extinction of the dinosaurs 65 million years ago. We know that we've been hit by chunks of rock on timescales of hundreds of thousands and tens of thousands of years ago. Siberia, within this century, by a small fragment. And people are starting to think much more seriously about the implications of this. In fact, we should be grateful that Jupiter is there. This is, if anything, this was kind of a demonstration of how fortunate we are that Jupiter is there. Because if Jupiter weren't there acting like this cosmic vacuum cleaner, sweeping up comets like Shoemaker-Levy, which might have been on orbits which would cross the Earth's orbit and would have a greater chance of colliding with us, Jupiter's out there getting rid of, on average, we estimate maybe half of these Earth-crossing comets and asteroids. And so if Jupiter weren't there, we might not be here because we might be hit twice as often, possibly 10 times as often, depending on one's estimates, and that might not have allowed people like us and life as we know it to develop on the planet. So that, we're seeing in real time in a process which is very important to the way life has developed on the Earth, and in the case of the dinosaurs, the way life ended.
So I'd like to thank you for appearing on our show this time, and maybe we'll have you back in the future and we'll discuss what they found out so far.
Well, it was my pleasure, and I just hope I don't have to wait till the next collision. That's in about 1,000 years or so.
Anyways, a few final thoughts on the comet crash. We should remember that a 10-kilometer object is not large. The solar system is full of stuff that's way larger than that. It's sort of the runt of the litter. It was one of these that scientists thought took out the dinosaurs. And contrary to what we or a lot of religious people think, we are not the most omnipotent beings in the universe. And sooner or later, it's a question of when, not if, we're going to get hit by one of these. And the question is, shouldn't we do something beforehand? There's been a lot of proposals out there to track these objects, send space probes to them so we can find out what they're made of and how we can stop them if we see one coming this way. To this proposal, a lot of people have said we don't have the money. Well, I'm sorry, we do have the money. One of these things hit, it's going to be ball game over. The comet won't care how much money you've got. we're all going to be gone. So for this month's edition of the Astronomy Show, I'm Barry Shanko. Thank you for watching. Good night.
The preceding program was produced through the facilities of Rogers Community 4, Vancouver. We want to hear from you and invite you to leave your comments and suggestions on our 24-hour response line message machine. Please call 731-5812.